All right, doing this problem called maximum product subarray. Let's have a read. Given an integer array nums, find a subarray that has the largest product and return the product. The task cases were generated so that the answer will fit in a 32-bit integer. This is one example. 2, 3, minus 2, 4. Output is 6. 2, 3 is the largest product, so this one has the largest product. Okay. Uh, because if you multiply by this, it becomes negative. Result cannot be 2 because, okay, so in this 2, 3 is the answer. In this, the result cannot become 2 because 2 minus 1 is not a subarray because of 0 in between. Okay, so there are interesting things that come. A 0 can come, negative numbers can come, which can affect your maximum product, right? Interesting. Let's switch to whiteboard. Let's take the first example. The first example was 2 comma 3 comma minus 2 comma 4, and we want to get the maximum product. So 3 times 2 was 6, which was great. And then when you do 6 times minus 2, it becomes minus 2. But if there was another minus, let's say somewhere here, then this entire thing would be nice, right? Other bit is if there is somewhere 0, then that divides. Let's say if there was a 0 here, then it would be another problem. Then probably again this would be the maximum one because this would be yield a negative. So this won't give good, and this won't give good. And the 0 will just make everything 0, right? So the points to note here is 0 is an interesting case. Negative numbers are interesting cases because negative numbers, even negative is good, right? That's another bit. So in general, how do we tackle this? So let's try and look at this. Let's try and look at maximum product subarray. So if you remember Cadence algo, which is used to solve for maximum sum subarray. And in this problem, instead of sum, we have got product. Now, can we use a similar technique though of Cadence algo and get towards that? So essentially, we maintain, let's say, a max, which is fine, a global max, which is fine. But let's say we keep track of primarily maximum product subarray ending at specific index, right? Ending at, so max product array or max product subarray ending at index, right? Something. So if I know my thing is I go through this array, and if I know the maximum product subarray ending at here, then based on that, can I find the maximum product subarray ending at here? What would it be? Again, so I'll call it maximum product subarray uh, at I. What are the different possibilities, right? Obviously, I have to take max of one. It would be either I just take the number itself, the same guy itself, right? That is one case. It has to come, right? So that is one case. Other case is whatever is the maximum product subarray, maximum product I can get from I minus one. I multiply it with a of I, right? But what if uh, all of this is positive and this is negative, right? And other case would be that this is negative and this is positive, and that's causing problems, right? So we have to know positive and negative is giving you negative, negative and positive is giving you negative, positive is good, negative uh, is also good. How do we handle all of that? Well, if it is negative, then we would want the smallest, or we'll want the most negative that we can get, right? And then we would multiply with this negative to get the maximum thing. So that would essentially be the minimum product subarray, right? So we'll call this max, and another option is, or we get min. Yes, right? I minus one, and you multiply it with a of I. Like these are the three different possibilities, right? It could very well be that this is zero, this is zero. So you have to consider all those three possibilities. So that's the general solution. Let's use this general solution to come up with the code. So what I'm saying is essentially, let's write a general solution here first. And general solution is max product. Let's call it max p of I equals to uh, max of a of I. Let's call it the nums of I, and nums of I times max p of I minus 1, and the other option is nums of I times min p of I minus 1. Alright, that's the general idea. So we want to maintain max p, we want to generate min p, and we want to generate overall max as well. So let's maintain this. So int max, and keep it as maybe 0, right? What do we want to maintain this as? I don't know. Let's take it to 0 to begin with, and we'll return max at the end. And we also want to maintain like a int current min p, current min product, and current max product. I don't like 0, so minimum give it large value. So for minimum give it integer dot max value. For max give it minimum value. So I go in command integer dot min value, and this also is, that's the integer dot min value. Okay, now we go for each num in nums. We have to update all three, right? Now I want to do have to be very careful how we do that. We want to definitely update all three, and let's call uh, new current max p, right? To begin with, one option is num, and then you can do new current max p equals to math.max of uh, the same thing, whatever this guy is, and num times, you could also take min, so this is another, or another option is you could have potentially multiplied it with current max p as well, right? So this is your new current max p, and obviously you will change uh, the current max p to this new current max p. But I also need to update, this is easy. This is definitely easy, and obviously max equals to math dot max of this and this. So max is updated, current max p is updated. How are we going to update current min p? Potentially just do like a same thing, or is there a simplistic way? So I can also do int new current min p. Again, this can also be num. or it can also be sort of same, right? So one of these two only. You do min here, you do min here, new current min p. So either you multiply with the min or you multiply with the max, right? So now you got this, you got this. So current max is this, and current maybe just put it here. Right, hope makes sense essentially. So I had the min p and max p to something, and now we are starting. Let's look at the first element. If the first element is 2, for example, right, then the current max p would be. I have a problem with the initial thing. That's my problem. So I would then suggest just take whatever the value is, which is I would do something like can the array be empty? No, right? So I would just give all of them the first guy's value. So I would give you nums of 0, I'd give you nums of 0, and I'd give you nums of 0 as well. And I'll do I equals to 1, I less than nums.length, I plus plus, and I'll do okay. Right, so a maximum product subarray, the maximum product ending here would have three combinations, either just this num or num into the max value, num into the min value so far, right? And similarly min, again minimum of these three things, and you update current max, current min, and you update the max, and that's it. Okay, submit. Get an error. Why do you get an error? Cannot find symbol. Which symbol? New curve min p. This is what? Is this not this? What's the problem? Okay, C capital. Submit again. And it works. All right.